Alrighty, lesson 5.3, solving trig equations. Now, 5.1, 5.2, we were working with trig expressions, which means it doesn't have an equal sign. Now we're going to solve trig equations, which means we're going to actually find values for the angle. And so the first thing we need to do when we're solving this is to isolate the trig function in the equations. So let's look at an example. 2 cosine theta equals 1. Well, we want to isolate the cosine theta, so we just divide both sides by 2. And it gives us cosine theta is equal to 1/2. Well, there's many values where if we're trying to find theta, you know that if we're just going to solve it algebraically, we would say theta is equal to the arc cosine of 1/2. If you put that in your calculator, you'll get a value of pi over 3. But that's only the first value, and you know there's more than one. So let's look at this graph of y is equal to cosine theta and see, if we were to pick the y value of 1/2, which is right here. So we want to see in all the cases where it's equal, we have cosine theta equals 1/2. So we would have like a point right here, and this is our pi over 3 right here. But it's also equal to 1/2 at this point here, at this point here, at this point here, or this point here, or this point here. So there's an infinite number of values that cosine theta is equal to 1/2. And so if we were to look at our unit circle, let's just go to the unit circle and say, okay, the cosine of where the cosine is 1/2, the cosine is the x value. So here we have an x value of 1/2, and that's how we get pi over 3. But also, it's flipped in the x-axis, we also have the cosine value equal 1/2 right at 5 pi over 3. And so there's, if we were to look at a domain of, let's say we're just going to look at one revolution. So our domain is going to be 0 to 2 pi. And that makes it easier to find 0 to 2 pi. And the cosine of theta equals 1/2 only at 2 places in 0 to 2 pi. And it's theta equals pi over 3 and theta equals 5 pi over 3. So this is what happens when we restrict the domain to just 0 to 2 pi. Well, what if we didn't restrict the domain? Well, let's take the first answer. Let's say we have theta equals pi over 3. If we were to go around the circle once, and so say like we were to complete a circle, so it's going to be pi over 3, and the whole circle is 2 pi. So we have our domain, if we're looking at a domain that goes from negative infinity to positive infinity. Cosine theta equals 1/2. It's going to be at theta equals pi over 3 plus 1 revolution, which is 2 pi, or 2 revolutions. And so the way we get around that, we just say plus 2 to n pi, and n is an integer. So this gets all of the values where cosine theta equals 1/2. It's here pi over 3 plus 2n pi. But what about the other one right here, the 5 pi over 3? And so it's also cosine theta equals 1/2 at theta equals 5 pi over 3. And again, this is going to be plus 2n pi. So all the problems that we have are going to be solving. The domain is either going to be listed as 0 to 2 pi, or it's like this, or it's going to be the domain is negative infinity to positive infinity. And so the answers are going to be different. You're going to be using the 2n pi when we're doing from negative infinity to positive infinity. Okay, so let's look at our first example. I'll solve sine answer, and there's going to to 0 to 2 pi. So all the problems that we have are going to be solving. The domain is either going to be listed as 0 to 2 pi, or it's like this, or it's going to be the domain is negative infinity to positive infinity. And so the answers are going to be different. You're going to be using the 2n pi when we're doing from negative infinity to positive infinity. Okay, so let's look at our first example. I'll solve sine x minus square root of 2 equals negative sine x. So remember, we want to isolate the trig function, which means get them all on one side. So we're going to add sine x to both sides, and then we'll add square root of 2 to both sides. So we're going to end up with sine x plus sine x. And taking the square root of 2 over on the other side, we have equals the square root of 2. So we add the two sine x's. We have 2 sine x equals square root of 2. So then divide both sides by 2. We have sine x equals square root of 2 over 2. So this happens to be on the unit circle, but if we get a value that isn't on the unit circle, all we have to do is solve for x. So x is equal to the arc sine, square root of 2 over 2, and that gives us a value of pi over 4, which you also see on the unit circle. But this is pi over 4. Oh, and I didn't give the domain on this problem. So let me add this. Let's say the domain was 0 to 2 pi. So this is the first answer, and there's going to be another answer. And sines are, the values are reflected in the y-axis. And so the other value where we have the sine is equal to sine of x is square root of 2 over 2 is going to be a reflection in the y-axis, and that's going to give us the second answer, x is equal to 3 pi over 4. And so those are all the solutions when the domain is restricted to 0 to 2 pi. You're only going to have two answers. And incidentally, the first answer is always the one that you're going to get on the calculator. The calculator will not give you the second answer. You're going to have to figure that out yourself, either by looking at the unit circle or in a way that I'll show you in a little bit. But so this is the second answer. And now, just as a follow-up, let's say if the domain was negative infinity to positive infinity, then our answers would be x is equal to pi over 4 plus 2n pi, and x, the second answer, would be 3 pi over 4 plus 2n pi. So that is if the domain is not restricted. Okay, example 2. Solve for sine squared theta sine squared x minus 3 equals 0, and our domain is given as negative infinity to infinity. Okay, so the first thing we want to do is we're going to add 3 to both sides. So for sine squared x equals 3, divide by 4, we get sine squared x equals 3/4. And now we're going to take the square root of both sides. So that gives us sine x equals, now don't forget your plus and minus square root of 3 over 4. And you can take the square root of 4 out of it, so it's going to be plus or minus square root of 3 over 2. And the plus minus is important as we go along, because this is going to give us 4 answers in one revolution. But yet we don't indicate that we have 4, and I'll show you why. So let's just start with, say, the sine x, and we'll take the positive part, a positive square root of 3 over 2. And you can look on the unit chart, and that gives x is equal to pi over 3. And the second answer is 2 pi over 3. So now take a look at the negative. Sine x equals a negative square root of 3 over 2. And that gives values of x is equal to 4 pi over 3. And the other answer is 5 pi over 3. Well, since the domain is negative infinity to infinity, we're just going to show the answers as x is equal to pi over 3 plus, and instead of going to n pi, we're just going to go n pi. And x is equal to 2 pi over 3 plus n pi. The reason we just write this as the answers, and it's n pi instead of 2n pi, because what would our answer be if n was 1? So let's say this n value here is 1. So pi over 3 plus 1 pi, which is 3 pi over 3, that's going to give us our answer, 4 pi over 3. And likewise, if this n is 1, we have 2 pi over 3 plus pi, and that answer is 5 pi over 3. So we don't have to identify these answers separately because they're included in the first two equations, pi over 3 plus n pi, and 2 pi over 3 plus n pi. Okay, example 3. Find all solutions of sine squared x equals 2 sine x. Well, when it says find all solutions, that's another way of saying that the domain is from negative infinity to infinity. Okay, so we have sine squared x equals 2 sine x. I'll rewrite it over here. Sine squared x is equal to 2 sine x. So we know we need to isolate the trig functions. Now, in other words, we want to get like terms on the same side. So we're going to subtract 2 sine x from both sides. And so that gives us sine squared x minus 2 sine x equals 0. So looks like we can factor out a sine x. So we'll factor a sine x out, and we have 1, or not 1, this is going to be sine x times sine x minus 2. And remember, always put the equals 0, because what this tells us is either the first term, sine x, could equal 0, or the second term could equal 0, and it would still, when multiplied, equal 0. So let's take them one at a time. So the first one, let's say sine x equals 0. Where does the sine of x equal 0? Well, it equals 0 at 0. It equals 0 at pi. It equals 0 at 2 pi. So it looks like we can say at x equals n pi. So there's our first answer. Now we're going to go to the second one. Sine x minus 2 equals 0. So sine x, we add 2 to both sides. Sine of x is equal to 2. Well, this is no solution. So why is it no solution? Well, it's because the range of sine x can only go from negative 1 to 1. If we have anything outside that range, we have no solution. So here's a problem where you have to check both answers, and then you have to see if they are legitimate answers. Now, one more thing on this problem, I'll put it as a note. And we don't start the problems like this by dividing both sides by sine x, which we're allowed to do. And here's why. So here's our original. I'll write it again. Sine squared x equals 2 sine x. Now, we could just divide both sides by sine x, and algebraically, that's okay. So what does that give us? Well, sine squared x divided by sine x, just sine x. 2 sine x divided by sine x is equal to 2. And so we would only have, if we started by dividing by sine x, we would only have this as our answer, and we already know that's no solution. We would miss this one completely. So that's why you don't start by dividing both sides by sine x. Okay, example 3, solving a quadratic type of a problem. So here's our problem. We have 3 cosine squared x minus 4 cosine x minus 7 equals 0. And it looks like this is a quadratic type, so you could either factor it, or if you can't factor it, you can use the quadratic equation. And in this case, this one we can factor. And so we'll look at the factors of 3 cosine squared x. That's going to be a 3 cosine x, draw parentheses. The other factor is just going to be cosine x. Okay, we notice that both signs are negative. So that means one has to be positive, one has to be negative. We don't know which is which until we maybe do a little bit of trial and error. But we do know, since our term is a -7, one has to be a -7, the other one has to be a 1, or plus or minus. And so by trial and error, we'll just do 3 cosine x minus 7 and cosine x plus 1. And then we check it, make sure it works. So when foiling it, we have the first term, last term are going to work out because that's the way we set it up. So, but then we have the middle terms, 3 cosine x times 1, and a -7 times a cosine x. So that's how we get our -4. So we factored it correctly. So this first term, and remember, these are equal to 0, so each term has to be equal to 0. So if we set the first term equal to 0, we have add 7 to both sides divided by 3 gives us cosine x is equal to 7/3. Well, right away we know this is no solution because it's outside of the range. Cosine can only range from -1 to 1. Anything outside that, it's no solution. So we'll go to our second. Cosine x plus 1 equals 0, so it gives cosine x equals a -1. Where does the cosine of x equals -1? That's only at 0. X equals 0, but since it said it didn't say what the domain was. So if the problem doesn't specify a domain, you just have to assume that it wants all solutions. And so this is going to be 0, it's going to be 2 pi, it's going to be 4 pi, it's going to be so on and so forth. So this just works out to be x equals 2n pi. Because when we get our first point when n is 0. So this is all solutions to this problem. X equals 2n pi. Okay, looking at example 4, solve 2 sine squared theta minus 3 sine x, not theta, x, plus 1 equals 0, and our domain is 0 to 2 pi. And so we recognize this looks like a quadratic, so we think we can factor it. And so this is going to factor to 2 sine x and sine x. And we also see that we have a negative here and a positive here. So that means we need to have 2 negatives. And then factors of 1, there's just 1 and 1. Make sure this works out, foiling them, and it works out. So let's deal with the first one. So we have 2 sine x minus 1 equals 0. So we have 2 sine x equals 1, sine x equals 1/2. And we know there are 2 places on the unit circle where sine x equals 1/2, so we don't have to put into our calculator x equals the arcsine of 1/2. This just gives us x is equal to pi over 6, and its mirror image in the y-axis, 5 pi over 6. So there's 2 of the answers. Now let's go to the next one here. So we have sine x equals 1 by adding 1 to both sides. And this only has one answer, where the sine of x is equal to 1. That's at pi over 2. And so this problem has 3 answers. And we box our answers. And that's it. Okay, the last example we're going to look at for part 1 of this lesson is solve 3 secant squared x minus 2 tangent squared x minus 4 equals 0. Well, a couple of things we notice at first. We have a secant squared term, we have a tangent squared term. And so in order to solve this problem, we have to use some trig identities to get either both terms as secant squared or tangent squared, or at least the same trig function. The other thing we notice is there's no domain given, so this means find all solutions. Okay, so we're going to start with the first term. We know we have a secant squared x, and we're going to change that using a trig identity. A secant squared x is 1 plus tangent squared x, so we have a 3 times 1 plus tangent squared x, then minus 2 tangent squared x, minus 4 equals 0. Okay, let's multiply out, distribute the 3. So that gives us 3 plus 3 tangent squared x minus 2 tangent squared x minus 4 equals 0. Well, we can combine the 3 and a negative 4. It gives us a negative 1. We also have a 3 tangent squared x minus a 2 tangent squared x, so that's just going to give us a 1 tangent squared x, or just tangent squared x. A 3 and a negative 4 is a negative 1, and that is equal to 0. So we can just say the tangent squared x is equal to 1. And then we're going to say tangent x, taking the square root of both sides, is equal to plus or minus the square root of 1, which is just 1. So tangent x is plus or minus 1. So now we're going to look at, well, let's say we didn't know this was on the unit circle. So we're going to solve this by saying x is equal to arctangent of plus or minus 1. Well, let's do one at a time. Let's just say the arctangent of positive 1. So x equals the arctangent of 1, and that's going to give us pi over 4. Now, remember that the period of tangent is pi and not 2 pi, so all of our answers are going to be pi over 4 plus n pi, because it's a tangent. That's the first answer. Pi over 4 plus n pi. Now our other answer, so x is equal to the arctangent of a negative 1. Well, we see that's equal to, if you put it in your calculator or look at a unit circle, that's equal to 3 pi over 4. And again, this is going to be plus n pi. Okay, so here's our 2 answers. This problem we had to first use a trig identity to solve it. And so expect a lot of those kind of problems to come up in the homework. So this is it for lesson 1. And lesson 2 will be, it'll have probably 4 examples and plus some other information that I'll give you. Okay, that's it.